Hello champions, this is Mr. Makokha Fredrick Matseshe, your tutor. Welcome to my first session, that is a higher national diploma under building and construction, civil engineering option. This is a unit called mathematics, and the first lesson will look at matrices. The content within it we have definition and notation, operation on matrices, matrix transpose, identity matrix, determinants and inverse of 2 by 2 matrix, determinants and inverse of 3 by 3 matrix, solution of linear simultaneous equation in 2 and 3 unknowns. Okay, now matrices are generally given in the form of A, B, C, D, that is matrix bracket. That is now inverse of in terms of row and columns, we call it a 2 by 2 matrix. Second, if given 2, 3, 1, 4, 0, negative 5, 1, negative 2, 0, matrix bracket, this is called 3 by 3 matrix because it has 3 rows and 3 columns. Number 2, a column matrix, these are matrices or matrix with 1 column, i.e. 1, 0, negative 3. That is a column matrix. We have number 3 as row matrix. A row matrix is a matrix with only 1 row, i.e. 5, 4, negative 2. And you have number 4, identity matrices or matrix is a square matrix whose element in the leading diagonal are unity, i.e. for identity of 2 by 2 you can see it is 1, 0, 0, 1, and a 3 by 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. The leading diagonal is this one. You can see there is a unity. That is 1, 1. These are 3 by 3. 3 by 3 identity, and this is a 2 by 2 matrix identity. We have transpose matrix. Transpose matrix. The transpose of matrix is obtained by changing the row to column and vice versa way. I mean, changing the row to be column and column to be row. For example, given that matrix 3, 0, 1, 4, 2, 3, 5, 2, 4, you want to get a transpose of that matrix. A transpose of that matrix will be 3, 0, 1, 4, 2, 3, 5, 2, 4. That will be now the transpose of the initial matrix. Now we have a singular matrix, number 6, singular matrix. A singular matrix is a matrix whose determinant is 0 or has no inverse. We have number 7, orthogonal matrix. Orthogonal matrix is a matrix whose product in the transpose gives an identity matrix, i.e. you have A multiplied by A transpose is equals to identity. That is orthogonal matrix. You have under operation, we have operation. Now let us look on operation on matrices. Operation of matrices. Now we have 1 addition. We have 2 subtraction. 3 multiplication. 4 we have division. Under first parameter here, we can combine addition and subtraction. Now number 1, let us look at addition and subtraction of matrices. We can note there on addition and subtraction of this of matrices, it's only done where 2 or more matrices can be added or subtracted when they are of the same order. Now they must be of the same order before you add a matrix to the other. Even for example, now example 1, given that A is equal to 1 0 negative 1 4 7 5 2 5 3 3 2 negative matrix bracket B 8 6 0 1 4 2 negative 3 5. Find A plus B, that is Roman 1, Roman 2, B minus A. The first one now, if you want to add, you are doing addition of A, matrix A to B and B, it will be now, you copy paste matrix A to be 3 1 0 negative 1 4 7 5 3 negative 2 plus matrix bracket 8 2 negative 6 0 1 negative 4 2 negative 3 5. So it means when you want to add this matrix, because of course they are of the same order, it's a 3 by 3, this is a 3 by 3 matrix. So it means you will add these elements, like 3 you add to 8, it will be 11. If you add 1 plus 2, that is 3. 0 plus negative 6, it is negative 6 still. You have negative 1 plus 0, it is negative 1. We have 4 plus 1, that is 5. 7 plus negative this one, it means it is 7 minus 4, which is 3. Then the last row, it will be 7 0 3. If you add this one to this one, you 7 3 plus negative 3, it means 3 minus 3, that is negative 2 plus 5, that is 3. Then the Roman 2, it was B minus A. It is now about subtraction. When you take now A, B as 8 2 negative 6 0 1 negative 4 2 negative 3 5 minus 3 1 0 negative 1 4 7 5 3, we have negative 2. So it means you subtract now 8, this element minus this element, the first row, the first column, that element, the second, which is this is B, this is A, because here we have B minus A. Now the result it will be 5. When you take this 8 minus 3, it will. What about 1 minus 1? It is 1. Negative 6 0 is 0 becomes 1. It is negative negative. What about when you take 1 plus 4? 1 minus 4, it means it will be negative 3. Here it will be negative 11. This one minus 5, it will be negative 3. Negative 6, negative 3, negative 3. It means negative 6, then 5 minus negative 2. It becomes now 7. That is all about addition and subtraction. Now for division, I think we'll move straight to a certain example under inverse for you to get the knowledge under multiplication. Now let us, for instance, let us tackle this question of this kind. Let us tackle the question, this question of this kind. Like you solve the equation 8f1 minus 8f1 minus 5f2 is equals to 4. 4f1 plus 3f2 is equals to 24. It means under solution, this is by inverse matrix method. Solution of it, first of all you form a matrix. And when you form a matrix, you just extract the matrix from the two equations. It's a simultaneous equation, but you apply the inverse method. So find it will be, now to form it will be 8 negative 5 4 3 matrix bracket f1 f2 is equals to 4 24. After forming, you find what you call determinant data, and determinant is equals to the prod of the leading diagonal minus the product of trailing, it is called trailing stroke other diagonal. Yes, now it will be, this is the leading diagonal, and the other stroke trailing diagonal is this one. When you put hand, this is the leading diagonal and this is the other diagonal stroke trailing diagonal. Now let us find that from our matrix formed, it will be 8 multiplied by 3 on the leading minus negative 5 by 4 on the trailing. So it means we'll have our determinant as 44. Now to find the inverse, first of all we must find the inverse. Inverse of that matrix is equals to 1 over determinant, then the previous matrix 8 negative 5 4 3 on determination of inverse. Those elements on the leading diagonal you interchange. So it means it will be 3 here and 8 here. What about the element on the trailing diagonal? It means you give the different, you give the opposite sign. Let me use that term, the opposite sign. So if here, from here, the form matrix, it was negative 5. Now you give it positive, and this was positive. Now you give it negative 4. Here now, when we set the determinant as 44, it will be now 1 over determinant for 4. Then you just copy paste this one, and this is the inverse of that matrix. of that matrix. Now, after getting the inverse now of the matrix, you attach the inverse above, which is this one, on the both side of the formed matrix, which is this one. Now you attach here and you attach here for you to proceed. So let us attach that one. I got 1/44. This is the inverse 5. This is the inverse. Copy paste the inverse here. It will be 4, 8. The previous one is here. The previous one is here. Say it will be 8. 8 negative 5, 4, 3. Then we have this one, the unknowns. F1, F2 is equals to, attach the inverse again. 3, 5, negative 4, 8. Then we insert, which was 4, 24. And we normally say, just take your time and multiply out this bracket. You'll get that it is coming to identity matrix, and we are dealing with a 2x2 matrix here. Now it will be identity matrix of a 2x2, 1, 0, 0, 1. From the equation now, from this equation, it means when you multiply this bracket to here, from here to this point, we will get this identity matrix, and we are dealing with that identity matrix. We are dealing with a matrix of a 2x2 matrix, which is now identity matrix of 2x2. Now we focus on the right hand side, not left hand side. Since the left hand side we have 1, 0, 0, 1, F1, F2. We deal with the right hand side, RHS 1/4, 3, 5, negative 4, 8. It means now it is 4, 24. Here again, you tackle the bracket faster before you link with this determinant. So it means with this fraction, it means now there is an operation of matrix. Now you can multiply this matrix. Now let us multiply this matrix. You want to multiply this matrix, you normally a matrix by multiplying row and a column. Normal multiply matrix taking row and a column. So we take 3 multiplied by 4 plus 5 multiplied by 24. It means now if you take this by this plus this by this, it is becoming now 132 here. And what about the second one? When you take the second row, negative 4 multiplied by 4, then plus 8 by 24, it is becoming to 176. And when you link, it is multiplied by 1/44. It means now the first one, when you multiply out, you multiply this by this element for you to get F1. And this one, the whole part of the fraction multiplied by the element 176. So it is becoming, when you multiply this one, 132 divided by 44, it is coming to 3. And 176 divided by 44, it is coming to 4. Now F1, F2 matrix is equals to 3, 4. This is your answer now. Yeah, we are done with that inverse method under a matrix that is 2x2, given the equation, the simultaneous equation. Now alternatively, you can use Cramer's method or Cramer's rule to solve the same equation, simultaneous equation. We have solved using the equation using inverse matrix method, but we can let us employ or use Cramer's method for you to solve that simultaneous equation. Let us apply the Cramer's method. Now, by Cramer's rule stroke method, we have 8f1 minus 5f2 is equals to 4. 4f1 plus 3f2 is equals to 4. So, step from this two equation, form a matrix as usual. So it will be now 8, negative 5, 4, 3. We have include matrix brackets f1, f2, 4, 24 is equals to. Now here we find the general determinant that can use this one, the general that. For you to get the general determinant, you just use this one, the formed matrix, which is 8, negative 5, 4, 3. It will be now, as you know, that determinant is equals to the product of the leading diagonal minus the product of the other diagonal stroke or trailing diagonal. Now it will be 8 by 3 minus negative 5 by 4, and that is 44 still. What about when we find, then after this one we find the determinant that for, we are using the unknown f1 and f2. Now let us find the unknown determinant for the unknown f1. Now it will be now for you to find the determinant for f1, we take the right hand side, this one, you substitute with this element on the first column of the formed matrix, because the first column is f1, the second column is for f2. Now it means we substitute this right hand side on the first column element. So it means it will be, instead of writing 8, 4, it means it will be 4, 24, negative 5, then we find now the determinant, the leading diagonal, the leading is 4 by 3 minus 5 by 24, yeah, and this is 132 as your determinant for f1. What about next? The first one we find we find the general determinant. Second, we find the determinant for f1. Now let's find the determinant for f2. Still we substitute the second column with the right hand side. We substitute this one, we do away with this one, we substitute with this one. Now it means it will be 8, 4, 4, 24. Good. If it is 8, 4, 4, 24, now to find determinant is 8 by 24 minus 4 by 4, it is 176, huh? Yeah, we are done. For you now to find f1 is equals to determinant for f1 all over determinant for f2. To get f2, we say it is determinant for f2 all over the general determinant, which is here the determinant for f1 is 132 here. And what about the general determinant is 44. Now we take 132 divided by 44. What about the second? The general determinant is 44. What about the second? That is f2. It is 176. This one for f2. all over 44. Here we have 3, here we have 4. So answer F1, F2 is equals to 3, 4. And this is your answer. That's why. Okay, now we are done with a 2x2 matrix. Let us check into neck. This is a neck paper. We have higher diploma in construction, building economics option, structural engineer option, building and civil engineer option, highway engineering option. We have this is mathematics, and you can see this is July 2021 series. When we check a question under matrix, we want to tackle this one. This matrix, this is a question, a neck paper. Given the matrix A is equals to 1, -1, -1, 1, 1, 2, and B to be 1, -1, 1, -1, 1, 0, 1, -2, 1. You are required to determine Roman 1, a matrix M, which is equals to A transpose minus B. Then Roman 2, we have M inverse. That is 11 marks. You can see it is 11 marks. Then part B of the question, you are told, or you are asked, 3 forces F1, F2, and F3 are in meganewton acting on a structure. Satisfy the simultaneous equation. The first equation is F1 plus 2F2 minus F3 is equal to 6, minus 2F1 plus F2 plus F3 is equal to 3. F1 minus 3, F3 minus 3F2 plus 2F3 is equal to 1. Use Cramer's rule to solve the equation. This is 9 marks and this is 11 marks. This is the whole part of matrix is 20 marks. Is usual 20 marks for this past paper. Now solution. Under solution, we say solution. Let us solve. Given the matrix you have, you are required to find M, matrix M, which is equal to A transpose minus B. Roman 1, M is equal to A transpose minus B. So it means now we take, for you to get this one, you want to multiply this one. For you to get M, you must know A transpose minus B. This is M. So for instance, let us take 1. This is matrix A. 1, -1, -1, 1, 1, 2. Matrix bracket. This is A. What about its transpose? You change. We said the transpose of matrix, you change column to be row and row to be column. So it means it will be 1, -1, 1, -1, 1, 2. You have 2 minus, this is A transpose now, minus B. B here was 1, -1, 1, -1, 1, 0, 1, -2, 1. Now let us solve. Let us start solving. Now we have A. This is A transpose. When you want to multiply this one, this is a multiplication of matrix. You multiply now. We normally multiply row, column. When you multiply this one, when you multiply, you want to multiply A then A transpose. It means you multiply 1 by 1 plus negative 1 by negative 1, which will be now 2. And what about 1 by negative 1 and negative 1 by this one? It will be now negative 2. What about negative 1 as you go? We normally multiply row, column, a row, then a column. So it means 1 multiply by this plus this by this. Negative 1 again to get the next. So it becomes now, when you multiply out, it will be, the last one will be negative 1 multiplied by 1, then plus negative 1 by 2. It becomes negative 1. Same you apply for you to get 2, 1, negative 1, 1, 5. Now this is A transpose. Now you subtract, you can see we are still under operation of matrix. 1, negative 1, 4, negative 2, 1, 0, 1. And operation of subtraction of matrix. For now, M is equals to, when you take negative 2 minus 1, it is 1. Negative 2 minus negative. Negative 2 minus negative. It is the same as negative 2 minus minus. It means it will be negative 2 plus 1, which is negative 1 still. What about when you take negative 1 minus negative 1? It becomes negative 2. Still we take this one, negative 2 minus negative 1. It becomes now negative 1 still. This is 1, this is 1, this is negative 2, this is 3, this is 4. Okay, and that is the Roman 1 part of the question. Let us go and tackle the Roman 2 part A of the question. That is the M inverse. The M inverse now. M inverse. The M inverse M. If given that this is M, we got M as this one. Now we want to find the inverse of this M. Now the inverse of this M, it will be now, this one is M, 1, negative 1, negative 2, negative 1, 1, 1, negative 2, 3, 4. From that parameter, yes. For you to find M inverse, you must find the cofactors. The cofactors. The inverse, M inverse, is equals to 1 over determinant multiplied by cofactor transpose. This is the same as the adjoint. Now let us find the cofactor transpose. For you to find the cofactor transpose, you must have in mind what you call sign placement. We have what you call sign placement. Sign placement for the first Roman, the first row is positive, negative, positive, negative, positive, negative, positive, negative, positive. Okay, we consider this sign placement. The first cofactor, let us call it cofactor number 1. We apply this, the first one. The first one is positive 1. We say it is positive 1, considering this one. Considering this one, the matrix, the initial matrix, just block the column, this column, and this row. The remaining part we take this one. So it will be 1, 1, 3, 4. Then the second, we take, the second is negative here. It is negative. Then we block this. We block this column and this row. The remaining components, it is negative 1, 1, negative 2, 4. Now it will be negative 1 1, negative 2 4. Second, the third, still we take this sign placement plus sign placement. We block this column and we block this. The remaining components is 1 negative, negative 1 1, negative 2 3. So it is negative 1 1, negative 2 3. The fourth one is 1 2 3 4. It is negative. This one we block this and we block this. We block this column and we block this row. The remaining components we have negative 1, negative 2, we have 3 4. 5, cofactor number 5, we have positive 1. We block this one. For number 5, 1 2 3 4 5, we block this column and we block this row. The remaining components is 1, negative 2, negative 2 4. Then number 6, cofactor number 6, we imply this sign negative 1, negative, still negative. It is number 6, this one. So we block this column and we block this row. The remaining part is 1, negative 1. We have negative 2. We have 3. Then number 7. Cofactor number 7 now. Cofactor number 7, using this sign, is positive. We block this column and this column and this row. The remaining part is negative 1. Negative 1. The remaining part, if we block this one, block this one and this one. Negative 1, negative 2, 1 1. So we have number 8, cofactor number 8. We have this sign negative. If we block this one, we block now this one on top here. This is the cofactor number 8. 1 2 3 4 5 6 7 8. Now we block this column, we block this row. The remaining component we have 1, negative 2, negative 1 1. Good. And the last cofactor now is positive. We block now this one, the last column and the last row. So it becomes 1, negative 1, negative 1 1. Good. Now let us work out to get those cofactors. Let us work out to get cofactors now. From the first one now, this was a 3 by 3. Now we broke down to a 2 by 2 for easy determination of determinant. Okay. Now you take, as usual, the determinant. To get determinant is the product of the leading diagonal minus the product of the trailing diagonal, which is 4 by 1 4, minus this 3. When you multiply this one is 3. Now it becomes, comparing the sign, the outer sign, positive, which means it will be 1. The second, when you take 4 by this one, it's negative 4 minus 2, that is plus. Now it becomes, considering this, it will be negative 2. Considering the outer sign, it becomes negative. So it means it will be positive 2. The third one, when you take this, it is 3 multiplied by negative 1, it becomes negative 3. Minus this one, it means it will be, considering the sign, it will be negative 2. It will be negative 1, sorry. Negative 1. And the fourth one, 4 multiplied by negative 1, it becomes now negative 4. Negative 4 minus 6, it becomes, then considering this one, the outer sign negative, it becomes -2, and this one, when you multiply out, it will be now 0. So consider for time, this one -1, and this one, the seventh one is 1, the eighth one is 1, sorry, the ninth one is 0. Now cofactors are this one. The first 3 is the first column of the cofactor. The first 3 and the second 3, that is the second column, and the last 3, that is the third column. So it will be 1, 2, -1, -2, 0, -1, 1, 1, 0. And that is all about cofactors. Now, what about cofactor transpose stroke the adjoint? Cofactor transpose, it means now you change the row to be column and the column to be row. So when you change it, will be 1, -2, 1, 2, 0, 1, -1, -1, 0. This is cofactor transpose. We find now the determinant, the general determinant. The general determinant now, after finding the cofactor, of course, for you to find the inverse here, inverse of m, the m inverse, it means you are required to find the determinant general, which is the general determinant multiplied by the cofactor. We have the cofactor, but we don't have the general determinant. Now let us find the general determinant here. Now it means it will be, there is a shortcut and there is a long cut. Let me use this shortcut. As long as you have this one, the matrix M, we say from the first row, you say what you just insert this one, you just take 1 into the first cofactor. The first cofactor was 1 plus -1, which was this one, into 2 plus -2, -1. So here, when you multiply out, it will be 1 minus 2 plus 2. This one is gone. We have 1 as your determinant. This is from the first row. Let us prove our determinant from the second row. From the second row, we say it is -2, 1 plus 3, 1 plus 4 into 0. It is -2 plus 3 plus 0. -2 plus 3 plus 0, that is 1. Still, let us apply the same to prove from the third. This was the third. And what about the second? The second, it is -1 into -2 plus 1 into 0 plus 1 into -1. This is 2 plus 0 minus 1. This is 1. So we have proved that the determinant, the general determinant, is 1. So now the answer, for we said that M inverse is equals to 1 over determinant multiplied by the cofactor transpose. That is the inverse of that M. Now it means it will be 1 over 1 multiplied by 1 cofactor transpose, 1, 2, 0, 1, -1, -1, 0. Good. Now the M in the M -2, -1, 1, 0. Good. This is your answer, M in. For the second question, question number 2. Number B. You apply the three forces, the three equation of the F1, F2, F3. You use grammars to solve the equation, and it is 9 marks. Let us apply the same. Given that the first F1 plus 2F2 minus F3 is equal to 6, minus 2F1 plus F2 plus F3 is equals to 3. F1 minus 3F2 plus 3F3 is equals to 1. Now we use grammars. You use grammars to solve it out. The question is strictly to use, has restricted you to use grammars rule, not any other method. Grammars rule, rule or method. So we say, first of all, as usual, you normally form a matrix. When you form a matrix, it will be 1, 2, negative 1, negative 2, 1, 1, 1, negative 3, 2, F1, F2, F3 is equals to 6, 3, 1. Yeah. As we have sign placement, positive, negative, positive, negative, positive, negative, positive, negative, positive. That is sign placement. Here we find the general. The first step, find the general determinant. That is, to find the general determinant, consider the sign positive here. We say it is plus 1 into, we say you block this, it becomes 1, 1, 3, negative 2. Evil. That is negative 2. Consider this one. We have considered this sign, the second sign on the first row. Negative 2 here. Take this one, negative 2. If you block this and you block this, the remaining part you have, the components are negative 2, 1, 1, 2, plus negative 1, considering this sign, plus negative 1, considering hey. Aya.